Seconds.
Okay.
There we go. That was the buzzer. I need your attention up here.
Can I get your thing?
We're going to need a volunteer, number 1 on your do now. Elliot, Kira's at number 1.
128. 128.
All right, number 1 is 128. Number 2, Tatiana.
128.
128. Number 3, Dale. And then 4 was 52, 5, 128, 6, 128, 7, 52. Remember parallel lines and transversals? Throw back to the beginning. In number 2, 1 was what, Nathan? 1 was 143, 2 was Diamante?
37.
37. So they were all either 143 or 37. You have cute ones of 37. Cute ones are 143. In number 3, what was number 1? 103. Number 2 was 77. 3, 77. 4, 103. And so on. Now we need to go over all of those. This is a throwback to when we learned the transversals. We will have our final on Thursday.
Why are you trying to get
That's a conversation we have another time. Final will be on Thursday. Again, this is, I told this last week, but just so you know, final is... I know, not right now. The final is on Thursday. It will count for all the things from geometry. So it's only the angle stuff on. No algebra, no quadratics, no parabolas on it, just the stuff we learned in geometry. There will not be a proof.
Yes.
Oh my God.
Now I just have to learn everything in geometry. Wait, that was algebra.
We only have 60 minutes for the final, so I figured that the proof would be too much time. I want to give you time to make sure you got everything else done. There are questions about angle, side, and stuff, but there's no proofs to write. The first thing we're going to do is go over angles in algebra. So we're going to go back and I'm just going to hit on the things just like we reviewed for the ECA. Same idea, short lessons, go over stuff. So if your back is turned to the board right now, turn around so you can see these first 2 examples. Actually, physically turn yourself, Kale and Marcus.
So this stuff is going to be on the exam?
This is going to be on the exam, yep. I need someone to read my objective. Marcus has volunteered.
We'll be able to solve problems with geometric diagrams.
Hang on, I'm going to wait until the girls in the front are going to listen to Marcus. Marcus, go ahead.
Students will be able to solve problems with geometric diagrams by applying concepts of algebra.
Thank you. Now,
I didn't
we're
even
going
say
to go.
anything.
Your attitude is not working right now. Laura. Your first problem up there, it looks like what? What kind of, how many degrees are in a straight line? Someone with a hand, please. With a hand, Ion Glover.
180.
180. So these 2 angles that lie on a straight line are going to add up to 180. So in order to solve this one, anytime you see supplementary angles that add up to 180, you just do 4x plus 22 plus 86 equals 180. So all that we did here, all we did was pull this 4x plus 22, put it here, the 86, put it here, just taking those 2 angles and adding them to 180. So right now, 30 seconds. Finish your algebra on that problem. 30 seconds, go. 30 seconds, go. Finish the algebra on that problem. You don't need to talk to anyone right now? This is the example 1. No one should be talking. You're finishing algebra on your own.
It's 90.
8.
No one should be talking. You're finishing algebra on your own. Answer.
I use the calculator. Yes, I use my brain.
Check your answer with mine on the board.
Yeah.
Check your answer with mine on the board.
Mr. Patteson.
Make sure you did your algebra right. Yes, Matt. You can plug it in if you plug it in 94. The x is 18. You're just solving for x today. If you would have plugged it back in, you got 94.
Huh?
You should have got x equals 18. If you would have put the 18 back in, you would have got 94. Now, number 2. Now, this is what I want to talk about because I know a couple of you had some minor issues with the do now, just looking at it, not remembering how this works. But whenever you see 2 parallel lines and something cutting through them, 2 parallel lines and something cutting through them, all of the obtuse angles are equal to each other. All of the acute angles are equal to each other. And then who remembers what the relationship is between the obtuse and the acute? What's that relationship? All of it, in this diagram. Kalia Johnson, you're having trouble with this. I'm talking about it right now.
Say what?
So if I have this angle right here, which is one of my obtuse angles, and this angle right here is one of my acute angles, how are they related? Here. Equal to 180. What's the fancy word for that? Supplementary. Supplementary, this is the fancy word for that. In this one, in this example 2, I notice that I have an obtuse, but I have another obtuse right here. So I know those are equal to each other. So when you run into problems where they're equal, so in this one they added up to 180, so we added them to 180. This one they're equal, so it's just 3x plus 17 equals 143.
Oh.
So when you visit cloud. So when you see 2 that are equal like this, that have the same value, you set them equal and solve. So there's 2 types of problems here. The angles either equal each other or they're supplementary. You might run into a couple that are complementary 90 degrees as well.
That makes sense.
So right now, what I want you to do, we'll finish this algebra quickly. The answer is going to be what? Someone has already done it? 42. 42. Answer is 42. Subtract 17. 3x equals 126. X is 42. What I want to see from you right now, we're going to switch into